KATI from Nigeria is a software engineer and an Auth 0 ambassador, passionate about mentoring, training other developers, and has also published over 150 hours of training resources on Udemy with 65,000 students. Wow. Talk today is about authentication, authorization, and security for modern client-side applications. Because no matter how much and how fast the web changes, there are three fundamental requirements for every stable business remain the same: authentication of the users, authorization of resources, and security of the data and access. Browser protocols are changing. Multiple authentication strategies keep coming. How do we implement authentication and security best practices for my specific business use case? We're going to learn so much more in this talk. Security is so important and often overlooked. Over to you.
Hello. Thank you so much for having me. It's a really huge pleasure for me to be here talking to you about authentication, authorization, and security for modern client-side applications. My name is KATI FRANTZ, and you can find me anywhere on the internet with my handle @badcoder, and I'm currently the core maintainer of a really amazing project called Tensei.js. And I'm also an Auth 0 ambassador, and I'm really passionate about authentication, security, authorization of web applications. So we are just going to jump right straight into the reason why we are having this talk. The reason why this conversation came to mind is because we have new frameworks, new ways of building applications every single day coming up on the internet, but the real requirements for authentication, security on the internet do not change. We need security. Our applications need to be more secure. The more time we spend on the internet, the more security risks there are. And every single year, we have the same types of security breaches, the same types of security reports. And that's why we want to address them. How do you keep having same old, strong and secure applications while building with the most advanced tools out there? That's why we want to have this conversation. Now, to know about security vulnerabilities, we are going to be talking about the most popular ones reported by the OWASP organization, which is a non-profit organization that is specialized in talking about web applications and security, authentication, authorization, the best practices to actually build a successful software business on the internet. So we'll pick up the most popular vulnerabilities pointed out by OWASP in the past year, which is 2020, and we'll look at them and actually talk about how we can secure applications against those. So the first part of this conversation is going to be focused on security, which I think you're going to love. So first of all, there's broken authentication, and we'll talk exactly about what this is. Basically, anytime there is a security breach as pertaining to authentication in your application, that's grouped under broken authentication. For example, a user's password is hacked, or a user loses their session or their session is stolen, that's going to be under broken authentication. There's cross-site scripting attacks, and this is when malicious code is executed on your website without your intent. So you build your really shiny React application and you thought you're done, but now a hacker can execute some code on your website, get some credentials, perform some actions without your user knowing, without the original intending user knowing. So that's cross-site scripting attacks. We'll talk about them. And we also have components with known vulnerabilities. And this is when you use a library, popular library that has a known vulnerability, and this causes an attacker to use that knowledge to kind of, get into your application, do some bad things. So we'll take each of these, and actually analyze, break them down, and understand exactly what's going on with these vulnerabilities. So the first one is broken authentication, and we are going to take a practical example of how broken authentication plays in real applications. So let's say you work at Stripe, and it's your first time at Stripe. It's a real fun time, and you build the bank account withdrawal functionality. So when people receive their funds, when merchants receive their funds, which are Stripe customers, they can add their bank account and then withdraw all of their money to their bank account. All right. So a Stripe customer walks into a cafe with her laptop, and she places down her laptop, opens it up, and wants to start working. And she's like, oh, I need to place an order. So she goes to order a pizza, and do not ask me which cafes order pizzas, and she forgets her laptop screen open. Okay, so what happens? Doflamingo, who is a hacker, has been following her around for days. And this is something very surprising about security in web applications. I find many startups that come to me for consulting, and they're like, how do we make sure refresh token authentication is working correctly? How do we make sure the application cannot be hacked using this and that? And that's actually not the most insecure parts of applications. The most insecure parts are just the daily security best practices that your customers might not implement, or your employees might not implement, that will give room for an attacker to get access into the platform. And that's the main source of authentication breaches. So in this case, Doflamingo goes up to her laptop, and since her laptop is open, what does he do? He adds his bank account and withdraws. And it only takes seconds for that to happen. And the withdrawal has been activated. She doesn't know, she's not expecting to withdraw anytime soon. So after about 3 days, her money is out of her account, and now there's a problem. So how can we remedy such a broken authentication system? Now, first of all, you have to enforce more secure passwords, and we'll talk about this, but most importantly, re-authentication for high-value actions. For example, you're building a web app such as Stripe, like we mentioned. Make sure that you have re-authentication set in place as a front-end engineer. No matter how modern your application is, you want to make sure that when there's a high-value action about to happen, you re-authenticate the user. Even Stripe does it right now. If you go to your Stripe dashboard and you try to add a bank account or withdraw, it's going to pop up and ask you for your password again. Doesn't matter if you just logged in 2 seconds ago, it would ask you for your password. Why? Because if someone opened their laptop in a cafe and a hacker was trying to get in, then that hacker would have a hard time because it's asking for the password. And now that's what takes us to our first point: ensure more secure passwords, so that no matter how easy it is for someone to hijack another user's session, because this is called session hijacking, then it's going to be more difficult if the password is difficult to guess or to think about. And this also cues into the sign-in process. If you're a front-end engineer, no matter how complicated it might be for the user to choose a really secure password, enforce that password registration security. Make sure that the user chooses a secure password. And there's OWASP actually makes a recommendation on how secure the password should be: at least maybe 10 to 12 characters, capital letters and small case letters, special characters, and things like that. Enforce that in your applications, no matter how boring they may be. All right, then inactivity timeouts to automate logouts is also a really good way to remedy broken authentication. If a user leaves their computer open and it's just open, what you can do is you can have a timer for inactivity. So you make sure that if the user does not interact with your website after a certain number of minutes, depending on how crucial your application is, this timeout might be a little lower. And if there's no inactivity, then you automatically close the user's session. These are some ways that you can make sure, number one, there's no session hijacking and things like that. And now we'll talk about the other parts of broken authentication, such as stolen credentials or stolen session IDs and things like that, in the next slides. But yeah, so this is the things that, no matter how simple they look, these are one of the top reasons why accounts are hacked, applications are insecure, as reported by the OWASP organization 2020. All right, so take this serious. Make sure that you're implementing all of these things. The more crucial your application is, the more of these you should implement. All right, so let's talk about cross-site scripting attacks, and I'll be showing you some practical examples so you kind of understand exactly what we're talking about. So you have a website and someone else runs code on that website intentionally to perform an action on that website, and we'll give a practical example of that. So this is dangerously executing user-provided data. This is one of the most popular ways for cross-site scripting attacks to occur. So I'm going to be showing an example, a practical example, and if you want to follow along, you can get the code from badcoder/xss attacks example on GitHub. That's the GitHub repository. So I'm going to open up my text editor here, kind of bomb this up so you can see, and I'm going to open the XSS attacks example, and this is just an index.html file. But just to show you around what exactly this is a React application, and I'm just using Babel inline so we don't have to worry about tooling. And basically what it does is, I'm just going to scroll right here. First we have an app component, and this app component has some search value, and that's in state, and the initial value is pulled from the URL. You can see we are getting windows.location.search right here. Then the use effect checks if there's search, and then it fetches products from the database. And then we have a nav bar here with an input search, and I will show you exactly how this looks. And the most important part, we want to show the results for, and we are dangerously setting inner HTML and displaying the search. Now let me just open this. I'm just going to copy the path of this file and visit the browser. If I could find the browser, minimize this. Now I would open this up in the browser, and if we look at our website, it's just Amazon hacked. So these are the results, and we have a search, and this is built okay, right? You can just search for something and then hit enter, and it shows you the result. That's the intent for this website. But now when we want to show the results, so there's this thing, dangerously set inner HTML, and this is going to be most popular in applications, for example, a commenting system where someone can comment with Markdown, and now you have to transform that Markdown from the database into HTML, and then dangerously set the HTML, or dangerously set the inner HTML into the page so that it can display the images and things like that. So this is normal. I've seen many applications built like this, and that's okay. But now, how is this susceptible to what we call a cross-site scripting attack? Let's take an example. So let's say just to show you one more thing that this application can do. Let's say I send you a link with search equals beans. Maybe I'm searching for beans. You can see that it autofills here, and then it shows beans right here. Okay, so this is functionality that is built into the application for a better user experience. Now I can send this link to my friend, and my friend can see the search results for what I sent. So the first malicious example that we have here is an image, and look at this image. It does not have a source, and it has on error. And on error is a function that the browser will automatically execute if you are trying to display an image with a wrong source, or if there's an error displaying that image. So this is default automated browser behavior. So a malicious user is going to copy this code and then place it in the search. I'll just paste it right there. Okay, and then they would take this link and they would send to a bunch, maybe they have 100,000 Amazon customers in their email list. They would send it and make sure their email looks as legit as possible to Amazon, and then they would require users to click on it. All right, so now when the user clicks on it, it's going to take them to Amazon website, then our demo application, and then it's going to populate the search. I'll hit enter, and if you can see, it populates the search, and then since we are setting the search, no matter what it is, into the DOM, we have this alert that says code has been run. And that means that we've executed malicious code from a hacker that just sent an email to a bunch of customers from our application, and now there's an alert on the page. But now, how dangerous can this get? Now I'm just going to copy the malicious sample version 2, and this is the same image, right? And the on error is going to be triggered by the browser. But now look at what it does. It fetches, it calls fetch, and fetch is supported by most modern browsers, and it's going to JSON stringify local storage and make an API request with it and send it to a domain, in this case example.com. So what I'm going to do is I'm going to open up my developer tools, and then I'm going to paste that in, or kind of expand this more so you can see. Then open up my network, clear this up, and then I would paste in that image directly there. So this is the link that maybe you click on the link in your email, it's going to take you here. You hit enter, and it looks like nothing is wrong. But now in the developer tools, if we check this out, you will notice, let's check out this request. You will notice the headers, And if we scroll down, you will notice that it makes a JSON request. You can see the content of that request, sending something that it looks like the JWT right there. So it gets everything from local storage, and that includes a JWT, and it takes that and it sends it to the website example.com. But this would be the malicious user's website. And now he has the JWT, and then they might have an automated system there that tries to perform requests on the user's account using this JWT to see if they can get access, right? So that's what XSS is, and that's how risky it is for your application. All right, so how can you remedy this situation? Number one, don't dangerously set HTML. So that's something that you have to be very careful about in your applications. You want to make sure that you are only setting content that you can trust. Very important. If you are going to render HTML on the page, have a scanner on your backend that can filter out all of these executable scripts and clean them up. You can do that on the backend. It's almost always preferable on the backend because the backend has maybe a larger variety of tools. You're not worried about bundle size and performance issues, but just make sure that you're very, very conscious about this. Once you begin to understand the vulnerabilities, you begin to know that, hey, every time I'm going to render some HTML on the page, I need to be careful, then it's going to come to mind. All right, then there's the second type of XSS attacks that we're going to talk about, and I'm just going to continue my presentation. And the second type that we're going to talk about is content security policy. Now, this is the first one we talked about, is when the user is going to send you a piece of code and then it would execute, right? Now, the second one is when the user tries to execute a link, a script. So the script is going to be in a link. So for example, a CDN link with the user's malicious code, and it's just going to look like maybe bootstrap.com, maybe the bootstrap.js package, but now it's not bootstrap. It's probably bootstrap with double P, but you wouldn't see it at first glance, and that would be the malicious user's code, right? So I want to show you how content security policy is used by Google and Facebook and how important it is to include it in your application. So I'm just going to escape and go into the browser again. Then I'm going to inspect. I'll probably start with GitHub, and I would go to github.com. And the network, I'm just gonna check the all, and what I'm looking for is the first request. This is github.com, and if I scroll down, the first request that gets the GitHub page, you will notice the response headers has a content security policy. Now, this policy is a policy that instructs the browser on which JavaScript is executable on the page, which JavaScript origin to trust. For example, now if you include bootstrap.com, jQuery, all the CDN links, the browser would just agree or assume that all of these are not malicious code, right? But this gives you an opportunity to control what the browser renders or what the browser executes. So you can see the default source is known, which means don't assume. Make sure you check out the list of all possible or all accepted scripts right here. So you can see it says, hey, you can allow scripts from self, which means if those scripts are from github.com directly, you can also allow scripts from githubapp.com. You can allow scripts from Amazon. This is the link. So you can see a bunch of links that are actually permitted to execute scripts. And this is very, 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 very important for your modern web applications. You want to make sure that you restrict the sources of scripts, because if a malicious user succeeds in executing a script on your computer or on your user's application, then that would have been avoided if you had a content security policy. So I'm just going to open up Facebook again just for another practical example. So you see that this is something that the top companies are actually using to make sure their applications are secure. I'm just going to scroll right to the top. This is facebook.com. And if you check out their response headers, I don't think I have the right one. Okay, this is the right one. So you can see their content security policy. You can see they allow scripts from virtualearth.net, google.com, facebook.com. fbcdn.net. These are the links that they allow through their content security policy. And now if the browser sees any of the links trying to be executed on this page without being in this content security policy list, it's going to block it. And that's really helpful. So you want to make sure that to avoid cross-site scripting attacks, you make sure that your application is not vulnerable. If there is a search or an input that collects data from the user and executes, then you want to make sure that those are clean. And also, if there is a way for users to inject default values, just like you saw the search, you want to make sure that the default values are clean. So you can pass those to the backend, make sure that you clean them up before you use them in your browser. Very important. All right, so that's how you can make sure that your application is not vulnerable to cross-site scripting attacks. All right, so because of time, we're just going to jump into the third one, which is components with known vulnerabilities. Now, very, very important right here. I think 2 years ago, there was an event and everybody was screaming, yada, yada, yada. Why? Because Lodash, a really popular package, had a vulnerability. And this vulnerability was almost going to expose every application using Lodash to a specific type of attack, right? And it's very important. If this is still one of the top 10 most popular ways for applications to be insecure on the internet. This is really modern stuff. So you want to make sure that you take this seriously. So number one, analyze and choose components and packages wisely for your applications. I've been in a couple of situations where someone asked, hey, why did you choose this package over this one? And my reason, number one, this one is maintained by a top company. It has a good number of GitHub stars. It has a good number of issues that are resolved every day. It has active engineers maintaining this package. It has the best security practices implemented for the specific use case. These are the things that you want to check before you actually choose a package to use in any of your applications, because as it could be just vulnerable and probably no one knows about it, but it would be exploited once you include it in your application. This is one of the most popular ways applications are hacked nowadays. All right, so second thing you want to make sure is cross-site scripting attacks. This is not something you want to. Cross-site scripting attacks are also something you do not want to allow these components to do in your application. For example, you might include a component, and then this component includes a link that is malicious, and you do not want that. Or maybe that component does not include a link that is malicious, but the component has a link that can now include a malicious link into your application. You want to make sure that you don't permit that. So also use a third-party dependency monitor, and the one I use for most of my open source projects is called Snyk. And what is this for? Is to make sure that every time you push to GitHub, it scans your packages, and then it scans its database of most recent vulnerability reports and make sure that you're not using any packages that are vulnerable. Really, really important. All right, so that's it for security best practices. We're just gonna jump straight into authentication because I'm running out of time. But authentication on web apps is a huge deal. It's a big deal, and that's what we want to look at today. So how do you authenticate your web applications, most especially single page applications? It's a huge question, and that's what we want to try and answer. So first of all, your traditional web application would have a browser. A user visits the web page, and secondly, the user would make a request on the login page to the backend. So your application would say login, and the backend is going to respond with one of two things. Either it's going to return a JWT, which is the first most popular way for authenticating single page applications today, or the second one, which is cookies. The backend is going to return a cookie and then set that on the user's browser, and that's how we would know if the user is authenticated. So which one of these should we be using? What are the advantages and what are the disadvantages? So first of all, let's look at cookies. The user logs in on the browser, it makes a request to the backend, and the backend sets an HTTP only cookie on the browser. Now this is different from a normal cookie, and we'll talk about why. But before we dive in to talk about why, I want to demo an application to you so that you understand exactly what is going on. Remember, we talked about cross-site scripting attacks. Now I want to demo to you an application that uses HTTP only cookies for authentication and how this might improve security in your applications. So first I'm going to open up my editor, and this is HTTP only cookies. I have a project specifically for this. So I'm gonna open up my editor and I'm going to cd into the folder, and in here what I want to do is run yarn dev. It's going to start my application, and this is using Tensei.js behind the scenes. Tensei.js just makes it absolutely easy to get started with any web applications that you need for the backend, CMS, authentication, everything you need. So I'm going to visit the application, and at the moment it's just a blank application. It has a login button, and I'm going to inspect to show you what's happening behind the scenes. So when I hit the login button, I'm just going to preserve logs, clear this up, hit login, and what it's going to do is it's going to make a login request to the backend, and this is going to send the email and the password. Right now, if we check out the request headers, you would notice that there's I think there was an old cookie, but the response headers has the set cookie, and this is the HTTP only cookie that is sent from the backend. Right, and this HTTP only cookie, remember when you set a cookie, you can do document.cookie to get the cookie, right? So if we do document.cookie, you can see that it has just an XCSRF token. This is something old on my computer, but the cookie that was set by the login, which is connect.sid, is not available on the client side. And this is probably the most secure way to build your applications, even when it's client-side applications. For example, right now, this is a Next.js application, and it's using Tensei.js behind the scenes, and Tensei.js just handles the authentication cleanly. So you can see what we are doing in the application. If I just open up the index.js, you will notice we are just making the request. And now, for any future request that we need to make, the cookie is set. It's a cookie is going to be sent to the backend for our API, and our API would automatically resolve the authenticated user. Now, the caveats, the reason why this is not very popular is because of the cross-domain problem. If you are going to host your application front end on maybe app.sas.com and host the backend on Heroku, then there's going to be a problem because the Heroku domain cannot set a cookie for the client-side SaaS application. There's no cross-domain support. Safari wouldn't let you do it. Maybe Chrome in some situations, but most likely not, right? So this is the way modern browsers have decided to go. So this is how this is the situation. If you are going to compromise on your security, if you're not able to control your domain, then you would have to you can't use the HTTP only cookies we are talking about, and this is the most secure practice for setting up authentication in your applications. Now let's look at alternatives, because at some point in your application building, you wouldn't have the luxury of a domain match, or using the same domain or subdomain in your applications. So what are you going to do in that situation? You are going to also, if you want to see the source code for this presentation for the cookies, you can visit my GitHub /HTTP only cookies, and the whole source code is going to be there for you to look at. All right, so what would you do? You would implement local storage authentication with refresh tokens and silent refreshes. We'll talk exactly about that, and I'm about to show you a bunch of more code, but please check out my GitHub to see the code /refresh token rotation. Okay, so let's talk about this. I'm just going to make sure that I start the right application. I would stop this one and then cd back into cd refresh token rotation, and I'm going to say yarn dev to start the server, and I'm going to cd into refresh token rotation app, and this app is a Vue.js app because we've talked a lot about React, and I'm going to run yarn serve, I think, and this should start up the client side application, the Vue application. I'll click that. Okay, so this is our Vue application, and this is actually the practice or the best way to implement, we'll talk about the practice or the implementation strategy, and this is recommended by the Web Application Security Protocol Organization. Hold on, let me find it for you. So it's an organization that is specific to the best practices for authentication for your applications, making sure that you they provide the best recommendations that you can implement, and it's completely open for you to read. So I think this is going to be refresh token rotation. There should be a link in this really nice article by Auth0 about it. So I highly recommend taking out time to read this article. But here, somewhere down in this article, there's going to be specific recommendations for implementing these strategies, and that's from the IETF. And this is a full guide that you can read at your convenience. It defines exactly refresh tokens rotation, which we are going to cover in a second. So what's this all about? Now, you can't afford to have your client and your server on the same domain. So what do you do in that situation? You're building a single page application. It's going to send you your JWT. Now, this is another scenario that I see most often. You just have your JWT, you save it to local storage, and then you use it to make your requests. And unfortunately, if you're going to have that token, then the token is going to be long-lived, which means probably 2 weeks, 3 weeks. And now if that token is hijacked by an attacker, which is a JWT, the attacker can use it as much as possible. Now, of course, you're going to make sure that your application is secure from such cross-site scripting vulnerabilities that can steal your token. But the attacker, if he ever gets his hands on it or her hands on it, is going to abuse that token until the JWT expiry, and there's nothing you can do about it. So refresh tokens is a much better way because you make sure that your access tokens are very short-lived. In this application right now, the access token is probably going to be about 10 to 15 minutes old. So which means that your JWT is going to expire in 15 minutes. And if it's stolen, then you can be rest assured that in 15 minutes, they'll be locked out of the system automatically. All right. So let's see how this works. First, I hit login. And 1 second. I think this account is temporarily disabled. Just 1 second. I'll make sure that this account is available for us to test with. We can manage our Tensei CMS France.com. Make sure I'm logged into the CMS, check out the user, and I'm just going to edit and make sure the user is not blocked, right? The user is automatically blocked when malicious activity is detected. Okay, so I think now we can refresh and try to log in again. Okay, so now we have a successful login. This is the login. What happens is it sends the email and the password. And now if we go to the application local storage, you would notice that there is a refresh token, but not an access token saved in the local storage. Now, the refresh token cannot be used to access information such as perform transactions on the user's account, but the refresh token can be used to get a new access token for the user. Now, if an attacker steals the refresh token, they can request a new access token from the user, and that access token is going to expire in 15 minutes. But now we have anomaly detection, and if this refresh token is used twice, that's why it's called refresh token rotation. If this refresh token is used twice, then the backend is going to block the user's account, just like we saw the account blocked right now. Now, this is very, very important because if the refresh token is stolen, then we know for sure that either your application is going to try to use it the second time, or the attacker is going to try to use it the second time, and it's going to block the user's account, which means keeping the user safe, at least until we figure out exactly what's going on. All right, so if we check out the network, you will notice that just as we had our application here, there's been about a couple of refresh token requests made to the server, and this request goes to the server and it refreshes to get a new access token every time we need one. And basically, what does this do? The access token is needed to perform authenticated request, And when you make a request to refresh a token, it's going to give you a brand new refresh token and a brand new access token. And that access token is going to expire in maybe 10 minutes. The refresh token, you save it again to local storage, and then you silently perform some refreshes. Now, this is a technique that is used by really popular services such as Amazon, AWS Cognito, and Auth0, and it's going to make sure that no matter how critical the situation is, if the worst case scenario is the user loses their account for about 10 minutes and the attacker can do anything in those 10 minutes, but it's better than the attacker having access to that account for 3 weeks or 6 months, depending on how long your JWT is. So that's why we have this practice. And I'm going to leave links so that you can learn more about this. We don't have a lot of time for me to explain exactly how it works, but also you have the source code so that you can learn more about this practice or how best to implement this. And this is a recommendation coming from the IETF. And they're saying, hey, if you're going to use access tokens and refresh tokens in your client-side based applications, make sure you use refresh tokens and refresh token rotation. All right, and Tente just does this out of the box for you. Now remember, using JWTs and just having a JWT sent to your front end, and then your front end just has it for about 6 months, is not secure. That token can be stolen, and if it's stolen, you would have to probably reset the JWT token, the JWT secret for all users of your application in order to get rid of that attacker, and that is not ideal. So you make sure you want to have a system where those tokens are more secure, such as refresh tokens and refresh token rotation. Now, another thing that some people have talked about is blacklist for JWT, and that's also a possibility. But it comes with some caveats, which we do not have time to talk about, but I'm willing to have a conversation if you want to reach out. Okay, so we've talked about a lot of things. I'm so happy that you followed me on this journey. My name is KATI FRANTZ. Thank you so much for following me on this journey talking about authentication. I'm always willing to have or answer your questions. You can definitely ask me any questions you have right now. I'll be willing to answer. All right, so thank you so much for your attention.
Kati, that was absolutely fantastic. Thank you very much for being part of this year's conference. I just wanted to pop up and prompt our audience to give you a huge round the world round of applause.
Kati, what an awesome talk. Thank you so much for that. We have some really great questions now that I'm really excited to hear your thoughts on these. So you have a question from Andre. Would you recommend more different characters, lowercase, uppercase, or longer passwords to increase entropy?
Yes, sure. So the main idea about having a more secure password is to make sure that the password is as unrelated to the owner of the password as much as unrelated as possible. For example, I choosing a password would be biased and probably choose something related to my mom's name or my birthday or a loved one, and you don't want to do that. What you want to do is create a password that is completely unrelated, and generators are the best for these. And that's why enforcing, lowercase, uppercase, different characters, numbers is the best way to go about this, because it's kind of not easy to use a name when all of these are enforced. So I highly recommend it actually using a generator, probably by a password store, so that it completely generates a password that is not related to you.
Do you recommend any password generators?
Yes, I think there's some really good ones out there. I think personally, for the companies I've worked at, I highly recommend, especially for employees, if you guys are a team working on a product together, and also if you are also cruising the internet alone, I highly recommend. I wouldn't say, but I've used LastPass and it's been awesome. I've also used a couple, but it's also been great. So I think you should just check out those that are really secure, those that have verifications, because there's like verifications they have to pass for security. Once you see that they're approved to use by large organizations, then I think it's secure enough for your use case.
Awesome. That's great. I think that ties into another question. Do you recommend a password safe? I'm guessing that's the same question.
Yes, yes, I do.
Okay.
It's really important.
Awesome. And another question, how do you test your application for XSS?
Yeah, that's actually very tricky. And there are automation software that do this. You just pass your application, you give it a bunch of instructions. It's like end-to-end test, and then they kind of put in like different sorts of characters. For example, if you've built your application for an English audience, and you didn't take into consideration Chinese characters or ceramic characters, these characters might be able to break your application. But with this automated software, they can actually test your application with different forms of characters. And this might be reliable, but the most recommended approach that I have is either being a QA person on your team or having a QA member dedicated to this. And what they would do is they would take the OWASP security recommendation list, and then they would test the application as much as possible for all of these. For example, if right now we are making a change on the registration form, then we're going to take the OWASP and then we are going to make sure that we check every box. For example, OWASP would recommend that before you take any input from your browser and actually send it to your server, you have data sanitization for that input. You also have escaping of characters, and then your server also, while receiving that data, should do the exact same thing. So that's the things that I would highly recommend actually testing manually. And of course, you can use the automated software. I've just realized that testing these manually and following that checklist might actually be very much more beneficial.
That's great advice. Thank you for that. And we have Andre asking about a VS Code extension from Sneak called Von Cost. Have you used it before? Do you recommend any others?
Yeah, so I think I mentioned Snake in the talk, and it's Snake is gonna check your package. If you're using JavaScript, it's gonna be your package to JSON. If you're using Python, it's gonna be your requirements file, and it's gonna scan the dependencies of your application. It could be any programming language, and it has a database of latest security vulnerabilities, and it's just going to make sure that your application does not have one of those vulnerabilities that were flagged. So on VS Code, I think it automatically just checks your package.json. I don't have it, but I think that's what it's gonna do. But I usually work on Teams. So what I do is I have an action on GitHub that automatically checks every push to the repository and every GitHub pull request, and it checks every package.json through the whole product code base. And if it detects any of those vulnerabilities, then it flags them and then automatically raises a pull request to patch the package version. So that I would recommend using Sneak wherever you can, VS Code, pull request, whatever way you can integrate it into your flow. It's free for most use cases. It's going to be very, very useful to make sure that you're up to date with the packages, making sure you're always secure.
So with the GitHub action that you mentioned, is that a Sneak GitHub action? That's if people want to go search for it, what should they search for?
Actually, once you sign up for the Sneak website, it's going to automatically inject itself to your repository. That's if you connect them. So if you sign up for a free account on Sneak, then it's going to ask you to connect your repository. And once you connect your repository, you don't have to worry about it again. It's going to inject those actions. So it's like GitHub checks. When you have a pull request, it's going to check them, and you're going to see it either approved, which means there's no vulnerabilities detected, or it denies it if there are vulnerabilities. So it's going to take care of this. You don't have to worry about it. If you want to find it on the internet, you just Google Snake, then you go connect your free repository, and then you'll be able to see those checks once you raise a pull request.
Awesome, that's great. I'm definitely going to have a look at that myself afterwards as well. We have another question about XSS, tongue twister, but via images and CSS. What are your thoughts on that?
Yes, it's kind of tricky, but the ways that this may be used against you is, let's say WordPress, for example. In WordPress, you have plugins that accept custom CSS. So let's say I wanted to customize my website, I would load custom CSS from a database and then display it on the page. So that's like allowing the browser to render something that's coming from an external source. So you don't want to do that. I think there are packages that actually scan for this before you actually save this data in your backend. And also for images, let's say you allow users to upload their images. So when they upload the image, then you save the URL. And then now on the front end, you're just um, taking whatever the image string is and then displaying it on the image. So this may also be a concern. So you want to make sure that before you take any images, any CSS, and display on your page, you can correctly validate where these are coming from. That's why before you even get to save the image and then generate the URL, you want to make sure that this is very clean. That's why you have to have validation, sanitization, really great checks on your backend, so that if anything is coming from your backend, you are very, very, very sure that this is secure. So also, like I think Andrew mentioned on the chat, you want to make sure that you have content security policies set up so that if it's coming from your backend, then it's fully trusted because you've done your validation, your sanitization, your checks. But if it's coming from an external source, you completely stop the browser from rendering the source at all. And I think that's one of the best ways that we have for securing your applications in most browsers today.
That's a really great advice. And I think it ties into the next and final question, which is, it's quite specific to JS modules. What would you recommend any JS modules to defend against these types of attacks, like purified user data?
Um, I I use every time I'm working with Node.js, I use indicative, but I think there's express validator. That's also some of them. But basically, what you're looking for is not only a validation library, you're looking for a sanitization library. So first you sanitize, you validate the data. For example, if you're expecting a number from the front end, then no one should be sending a string with angle brackets, right? So you validate and make sure that it's a valid number, and then you sanitize because you want to make sure that the data is a number. Yes, it's a valid number, but what if there are extra characters that could not be detected by the validation library? You want to trim out any extra characters. You want to trim out anything that looks like a string because it passed validation, but actually looks like an SQL query. You want to sanitize those out. So most validation libraries will have two components, sanitization and validation. That's what you should check out for if you're looking for a validation library to use in your applications.
That's a great way to end. I think that concludes it perfectly. So thank you so much for that. I know I learned a lot. I know everyone watching would have learned a lot as well. Kati, thank you again so much for your awesome talk and your awesome Q&A.
Thank you. Thank you guys for having me. Really
Everyone,
exciting.
everyone who is watching, don't forget to go and follow Kati on social so you can keep up to date with all the awesome work and projects and tips that Kati is sharing on socials.
Thank you.